Zoom Conf en mode cool, effectivement. Des collègues qui avaient fait beaucoup du protocolaire, mais on n'a juste pas mis les bières sur la table parce que ça c'est... Non. Ça déroule. Voilà. Okay, dear colleagues, it's a great pleasure to see so many people attending the conference on site and being in person in this amphitheater. I'm just here to open the keynote, and I will give the floor in a few seconds to my colleagues Gulgun and Pierre. They are the local representative for this keynote. You are both at, no, you are CNRS and Grenoble INP, right? Only all Grenoble INP, great. The talk will deal with structuring research activities around transformative technologies for Industry 4.0 or maybe 5.0. It's your challenge now to switch and explain how will be the future. Okay, I will give the floor one more time. Thanks to be here and enjoy the conference. See you later and during the coffee break and so on and so on. Please.
Welcome everyone to our institution and to Grenoble. We will be presenting this talk in duo. So I think it's a good idea after the lunch, and we will try to keep you wake up. My name is Gulgun Alpan. I'm professor here at Grenoble INP at the Industrial Engineering School. And I'm with Pierre David, who is also professor at the same institution. So the agenda is the following. So we are local here, and we would like to give you some highlights from our research activities at the g-scop Research Lab. We will in particular focus on model-based systems engineering and artificial intelligence for supply chain management. And we are also developing technological platforms, technological centers, and integrating Industry 4.0 technologies in these technological platforms. So we would like to extend our vision on how these Industry 4.0 technologies can support research activities and vice versa. So this is the main agenda here. And I will give the floor to Pierre.
Thank you, Gulgun. So the purpose of the talk is to explain why we want to develop some platform to advance the way we are doing research here in Grenoble on the topic of deploying the technology from Industry 4.0. So a lot of companies come to us with this question, and if we think about that, we know that we need an approach that is mixing many parameters to decide in the company to introduce a cobot, introduce any kind of robots or anything like that. They have to think about the invest, the technical compatibility. Do I have the skills, the operator skills to manage that? Do you have the maintenance skills? So you see here a lot of problem linked to more technical point of view. What will be the effective benefits? Can we get this by simulation, by this kind of approach? But also, we need some input from sociology, economy, management science, and so on. So we try here to network with our colleagues from all these domains to answer this kind of question. So our key directions to address this question is to find methodology to handle the complexity of the future production systems, to understand how we will work with the evolution of technology in new industrial strategies that you know, circular economy, personalization of products. And we also want to work with new definition of the performance of those production systems. It's not only operational excellence, it deals also with sustainability, ethics, and so on. And we want to go beyond just collection of technology, so we need a systemic view of the production system and think about, of course, the place of human in all these systems.
And of course, artificial intelligence is also one of these transforming technologies in Industry 4.0. So we have research on artificial intelligence applied to production systems, especially for predictive analytics, and to add some more dynamics to our existing optimization simulation tools. And we will also we are also looking at new ways of testing and validating our research using such technologies. So the technological platforms, technological labs that we are building up can be used to generate more controlled and generic environments than maybe industrial settings for validating and testing research outputs. And also, since we can simulate physically these industrial environments, controlled industrial environments, we are hoping to get some more realistic data than mere computer simulation. So we will talk about this in a few minutes.
So some few slides about systems engineering for production systems design. We are addressing the question of introducing technology in the plant. So if we look at what are the way industry is treating that, they are working with small set of criteria, cost, safety, to decide if they are putting new robots, for example, in the shop floor, or they are just testing commercial offers that they have seen in demonstration. They are using a lot of industrial benchmark, just so to take the decisions. They see if it's work for a similar plant and they try it in their own. For the most advanced one, you can find industrial doctrines like just strategy. We want to always automate. We want always to put new technology in our plant, for example. And sometimes there exists some domain-specific guideline that come from the literature and experience from manufacturers, like a guideline to decide to automate or not an assembly task or things like that. And in the literature, the way the introduction of new equipment is treated is mainly done by equipment selection method, for example, using operational research or multi-criteria decision making, or sometimes they are building some guidelines and some way to perform audits in the shop floor. You have to decide to automate or not some part of the plant. And as you have seen in the introduction, we would like to develop a more global view of all of this. So we propose in our research team to adopt model-based systems engineering to get a more global view of all the problems linked to the introduction of this new technology. So we are working on the four big phases we have in systems engineering and defining the need and the requirements for this new technology in the production plant, about defining the architecture, assessing those alternatives to select the good solution. So we are working on the models and ontologies to efficiently define the need and the requirements and to have some input data to generate some architecture using operational research algorithm or CBR techniques. And we are also working on generating the performance evaluation models that we will need to identify if the introduction of the technology is good for a global point of view to the production systems. And we're also working to close the loop with multi-criteria decision-making techniques to take the right decision. So just to give a small example, we are currently working on a project to design the new material handling system for internal logistics. So the decision is the problem is to decide if I have to put autonomous robots, real-time location systems, cobots, and so on, augmented reality devices for the internal logistics of my plant. So we want to propose a new design process to make the best decision about taking or not this equipment and how mixing them. So we have worked on the different phases you have seen. We have worked on defining language to make the material flow analysis, which is kind of need and requirement analysis for these internal logistic systems. And we are using this to get data to create some solution alternatives that can treat this flow to handle in my plant. And using those model-based representation, we are able also to generate some evaluation performance models, like, for example, using CMIO, or you can use also Arena on every kind of software of discrete event simulation. And on the other side, we are building model and guidelines to analyze the business case of the company, to get the criteria about the invest, about the operator of the skills of the operators, and all the important indicators that are not about the operational efficiency of the system within the decision. And we are gathering all this information in multi-criteria decision-making tool to take the right decision and to select the good system to propose for this internal logistic system. So when we are doing this kind of project, we face the problem of validating those design process or the kind of solution we are proposing for an industrial case. So by now we are doing industrial cases analysis. So we are working with company, we are testing the design process, we are testing the solutions that are given, but we are just giving proof for one cases. We are also using computer simulation to test it on other kind of system, but we have only a few representation of all the problems that are linked to the introduction of this system. So we try to find a third way to validate something which is more generic than the industrial cases, but more realistic than a computer simulation. And this is the purpose of the platform we will present you at the end of this presentation. No, I give the floor to Gülgen.
Thank you. So this part was the first part was related to model-based systems engineering. Now I will give you some highlights on what we are doing on artificial intelligence for supply chain management. So I'm heading a chair on Industry 4.0. Which is called AI for Data-Driven and Self-Reconfigurable Supply Chains. It's a part of the Multidisciplinary Institute in Artificial Intelligence. For those of you who are coming from abroad, maybe you haven't heard about these institutes. French government in 2018 wanted to create huge institutes on artificial intelligence because they would like to promote the use of artificial intelligence to solve societal issues and also for open data. So there has been an open call. 12 sites from France have sent some projects, and only 4 of them are selected. And one of these 4 artificial intelligence institutes in France is here in Grenoble, and it's called MIAI, Multidisciplinary Institute on Artificial Intelligence. So some numbers very quickly. The numbers are growing. I just have here 2019, 2020. 350 permanent researchers, more than 100 postdoctoral and doctoral students and engineers, many industrial partners, and the institute is configured around 31 chairs. So one of the chairs is the one that I'm piloting, that I will give you some more information in a while. So research domains are related to, of course, artificial intelligence and application areas, as you see. The one that interests us is on Industry 4.0. For more information, you can go and check. I will not have time to explain, but there are great activities both on research and teaching and feedback to industries. So please visit the website. So in our chair, we are 7 senior researchers. We have a junior team of 5 doctoral students and up to now 5 master's students, but each year we recruit other students. Industrial partners that some of them you may know, and some others, for example, KLS Logistics is a local company. And relations, international partners, 2 international partners from Germany and 1 from UK, Swansea University. Our roadmap is the following. We have a founded background on simulation and optimization. So we would like to mix these simulation and optimization techniques, enhance them using artificial intelligence. And artificial intelligence here is really in the broader sense, not only data analytics and machine learning, but also reasoning type of artificial intelligence or knowledge representation. Objective is to develop novel decision-making methods to have a higher reactivity in supply chain management. Because optimization and simulation, they sometimes may have some lack in dynamism as the system evolves. So we would like to use the AI to capture system dynamics, and to add it to our optimization and simulation techniques to enhance the prediction and forecasting capabilities of such methods to cope with uncertainty. And of course, we would like to benefit from data, which is now more and more available. And we will see maybe less and less sometimes. I will get to that in a while. We have many projects inside the chair. I'm not going to go in details of all of them. I'll just give an example in order to tie up what we would like to do using the technological platform. So I will just pick an example. I just picked an example and to show you some difficulties that we may have when we are dealing with data, and maybe some of them you have already dealt with in your own projects. So the case is data analytics for stock capacity planning in hospitals. It's a very current issue, but shortages and overstocking was already a problem in hospital pharmaceutics before the COVID period. And it's also known that the pharmaceutical costs account for a lot of money in hospital expenditures. And our partner company is working on warehouse WMS constructions, so warehouse management systems construction. So when they dimension new stocks for new hospitals, it may take them a long time period with very much back and forth corrections. So we would like to, objective is to predict the consumption of medicine in hospitals using past experience for sizing and managing these pharmaceutical storages in a shorter time period and in a faster manner, at least reduce this corrective action period. So the idea is to use data from existing hospitals, get some features which are impacting this consumption, and try to estimate the drug consumption of a new hospital which wasn't in the training set. So I will give you some examples of difficulties in this project, which are, I believe, existing in many industrial projects, because usually industrial data is, you know, we have a lot of them, but when we start looking at the quality of the data and start cleaning this data, we end up seeing that there are a lot of holes in this data that we have to be we have to fill in. We had this problem especially in product database, because pharmaceutical products now they are getting standardized, and there's a standard code, and this standard code has to be inserted in the hospital database. But these are new regulations and new standardizations, so some existing data may not have this. So we had to cross-check this data with some other common data sets like FAST, which is the database for the pharmaceutics, or also from completed from other sources like governmental sources and so on. And even worse, some medical units in the hospitals are not standardized at all. So when we would like to map the functioning in one hospital, it may be completely different in another hospital. The structuring is quite different. So when we try to structure all this data, we see that it's quite tedious, and sometimes we may lack actually even in the immensity of this big data. When we start cleaning it, we may get on some issues very reduced data sets, which are usable. I will also show you some results. Of course, we were able to get our databases. It took us some time, but we arrived at a good and clean database. And I will show you some results. I will not only show good results, but I will also show some bad and ugly results, the good, the bad, and the ugly. Okay, so here are some data from for a medicine from 5 hospitals. We used 80% of the data to train this set, and what we are showing here is the estimation for one of the hospitals, which was in the training set. The blue line is the true value. So the good result is the one which is shown with the orange one. It was we tested several supervised learning techniques, and the random forest was quite good. The red one is the one which was preconized by World Health Organization. So you see, it's quite bad, because it's just maybe predicting a tendency. And the ugly one is the yellow, the green one. You know, basically it's maybe predicting the average. Okay, so, and this is deep neural network. Why is that so? Because we didn't have enough data to train this. And you see, maybe you don't need to do deep neural network to estimate the mean value of some data sets, right? So here, if we, of course, a continuation of this, now if we would like to make an estimation for a hospital A or B outside the training set, the random forest was quite good for one hospital, hospital A, but not great for hospital B. And, you know, deep neural network, he was lost. So now we said, okay, it's not fair for deep neural network. We didn't give him enough to eat. Let's give him more to eat. So we increased the data set, multiplied data set by 150, okay? And he started waking up, okay, here on the below side. Not great yet, but he's waking up. And it was better for maybe for the random forest on the right-hand side. So what do I want to say with all this? What I want to say is that actually many efforts are needed when we would like to use these machine learning techniques. And this is not only in this case, but in also in industry, the data is multi-source, and cleaning, consolidating, removing conflict data takes a lot of time. Data availability is also an issue. We had to cross-check maybe 4 or 5 databases to come to a clean database. Most of the time, we would like to understand why it's not working, why random forest was working, and why the other things are not working. So it's important. We always say that these techniques are generic, yes, but it still needs a modeling and training effort and a lot of energy. Like I said, you know, if a deep neural network is just estimating the mean value, I mean, we have a better way to do and much easier, much faster way to do that. And the other issue is that, you know, sometimes these are industrial data that we may not be able to share. Here, our problem is when we like to share data, when we like to train data, we are lacking some data sets. Deep neural networks were quite well performing because we had these cat pictures everywhere, dog pictures. There are these all huge amount of databases already existing and being shared. And in industry, we are lacking this standard benchmark data sets. In some disciplines, for example, in vehicle routing problems, we have shared data sets, but I think it's important for us, for our industry, you know, production community to think about this standardized benchmark data sets so that we can test the problem data that we have. So one of the things that we would like to do is to use our platform to generate realistic data sets that we can later on render as open data sets. So since it's a physical platform, we can emulate these activities. We can generate an industrial setting and emulate. We also have expertise in simulation and digital twins. You most probably, I mean, I have been working with Frédéric Noël, and you all know Frédéric, who is working on this issue. So we have several industrial projects, and we now have we believe, good expertise in that, and we can build digital twins of these platforms and learn from the configured workflow, from which we get some real data, and then complete this data sets through simulation. So I will leave the floor to Pierre again.
So know some few words about the platform, operations management platform, that you will be able to visit tomorrow morning. Just a few words about the institution. The platform is operated by SMART, which is a network, a national network of technological platforms. So if you are interested in sharing some experiences and having benchmark about technological platform for research and for teaching, this is the good institution to contact. Here in Grenoble, we are working for 3 universities and different research centers, and so we are operating some platforms to exemplify the technology of Industry 4.0. So we have platforms about cyber physical systems, about additive manufacturing, and one of them is the operations management platform, which just started in September and which will be the support for our research activities. So the operations management platform is built to be a flexible workshop environment. We don't want to create a fully automatized, highly robotized production system, but we want a flexible workshop that can be configured as needed, sometimes to exemplify some global supply chain, sometimes to exemplify an assembly workshop, and so on. So it is highly equipped with data collection and management facilities like real-time location systems, QR codes, tablets, and manufacturing execution system. And we are using within this platform some kind of user-friendly robotics like autonomous mobile robots or cobots to study how they can be used in a real manufacturing plant. So the key issues we have, so we are sorry, we are just sharing with you our issues and not the solutions. So our issues are to build some relevant case studies because we want case studies that are representative of industrial cases type, not just representative from one case study, but we want something that will help us to prove that the results of using one technology on another are true for a set of the industrial cases. So we want also some cases to be able to test unitarily every different technology from Industry 4.0, just to see if the introduction of one of them is changing something about the whole production system performance. And we have also a big issue is that we need some experiments that are realizable within a day with new people and mainly with students for our case. We also work on the experimental protocols to get true results that are exploitable in research and that are really usable for validation purpose or demonstration purpose. So we have to master the variabilities and the biases that exist in the case study. And we need and we have to ensure the repeatability of the results that are obtained, which is quite hard because we have a lot of humans within the system. And we have to allow the registration and the post-treatment of all the data. And this comes to the last point here we have to think about how we will share the result with the scientific community and with all researchers in the lab. So how do you encode an observation of a full production plan, including following the operators, following the efficiency of the production, and so on. And so the main wheel that we have is to build some benchmark data sets, for example, to provide some data for artificial intelligence feedings, and also data sets to allow the community to verify and to validate the results of one proposal of design process of a production system, of being able to give the demonstration that a new technology brings some enhancement to your production situation. So our conclusion and potential is we want to generate realistic open data sets. So through emulation with the platform completed with simulation, computer simulation, and digital twins development. So we want to propose to the community a physical benchmarks of industrial situation for validation purpose, to develop the demonstrators for the digital twins and test bench for new technologies. You can call it 4.0 or anything .0 you would like. But as you have seen, we have still a lot to do, and we would like just to share those first thinking with you. So thank you for your attention. We hope you learned something with us.
Thank you, Pierre, and thank you, Gülgen, for this very interesting speech. Maybe a lot of questions by our colleagues. Who wants to open the Q&A session? Please, Clément. I'm sorry, I don't know exactly.
5.
Attends.
Vas-y, teste. Celui-là, vas-y.
Ah, c'est bon.
No more questions?
Technical issues.
Thank you very much for a very good talk there. My question has to do with the digital twin of the manufacturing system. Obviously, a hospital is a very complex, and the manufacturing is also a very complex system. How do you see the establishment of the digital twin, and when you are going to have a real digital twin compared to just a simulation model? How do you differentiate, and how do you support that? My question.
So this brings back to the definition of what a digital twin is. I know that there is a working group in France, at least, who are grouping people, and I'm not quite sure if they come up with a definition of this. But what we mean here is really we would like to connect. There's this physical part, and there is the numerical part, and this physical and numerical part are communicating with each other. So it has to have some connection in between. So we know how to do simulation, but we have to the simulation has to be aligned to the physical part of the system. So, and they need to have this connection in between.
Thank you. Maybe second one, what do you see the role of AI into this loop of the digital twin?
I will give an example to be concrete. I think that there can be many ways to connect them. But what we observe is when we make this connection between the digital and the real world, if you would like to, for example, sometimes the industry companies would ask us to say, okay, what I would like to know is that I am my system is at this point, and if I do this, what may happen to my system? Okay, so this means that we have to launch a lot of simulations offline, maybe, but to get the answer really quickly. Okay. So, for instance, artificial intelligence can help us to not to test all possibilities, because we can only test. Artificial intelligence can help us to target some promising scenarios to test, and we can train it on the past data to be able to choose these promising scenarios. This is an example, for instance, of how we can use the artificial intelligence together with the digital twin.
There is an initiative in the United States called AC for AI, AI for AC. It's run by the SERC, Systems Engineering Research Center. It's a virtual center founded, I think, by NSF. I don't know. This is related to what we're doing at INCOSY. So do you know this initiative? Or? Yeah, okay. Because I like to know what you would think about that, because they think about artificial intelligence with the new way of thinking about artificial intelligence with the neural networks and things like this. We have a different approach. In my chair at Centre Supélec, we try to map the multi-agent approaches in AI with a system of systems in system engineering, and try to find some correlation between this and the commonalities and the differences. What do you think about that?
This is a good. This is an interesting path, maybe, because some partners, industrial partners, the questions that they would come and ask us is, how do I know? They want to use AI, okay, and they would like to know what to use in what case, okay. So for me, if I understand well your approach, this might be this type of case where you try to maybe standardize the problem types so that we can get aligned with some techniques. I'm not very familiar with the systems of systems. This will be maybe more Pierre's case, but I believe what you're doing is to maybe get a standardized representation of what you're seeing. So in that sense, maybe this can help for the questions of, okay, I have this problem. What technique of AI is interesting to use for me? And from our point of view, when we would like to characterize the problem types, it's quite complicated. It's quite complicated because we have to say, oh, okay, this is a production planning problem, and there are too many sub-problems of production planning, and so on. So this characterization, if you would like to answer this question of industrial partners, is quite complicated because there may be standard problem types, but also a lot of very particular industrial constraints which changes completely the way that we should attack a problem. So otherwise, I mean, if you can explain us how your chair helps in this type of problems.
I tried to introduce that this morning during my talk.
Okay.
But the thing is, we are trying to develop a knowledge representation for systems that is based on previous AI development in multi-agent approaches. But not only that, I mean, we found a lot of commonalities between multi-agent models in AI and systems of systems.
And knowledge-based systems, what we are also doing with Swansea University is actually trying to see how we can couple the data, the data-driven AI techniques with knowledge-based AI techniques, because in companies, actually, some of the things some of the knowledge can be captured by data, but there are many knowledges which are at expert level, and this type of information may not be easy to extract, or it may even not be extractable from data. So we are looking at this problem of hybridizing knowledge and data techniques. My colleague Abdourahim Silla, who is there, is expert on this knowledge-based techniques, and so we try to develop this part, which should start in September. Thank you.
Maybe I can complete a little bit the answer about the work, the connection that can be made with AI technique and model-based system engineering and system engineering. So you know that you have many opportunities for need elicitation, requirement analysis with language analysis techniques, and also we need some new helps to generate alternative and of solution, to generate architecture and things like that. And we'll see also a lot of debate when it's coming to explainable artificial intelligence. If you have safety relevant system, and that for which you need to prove why did you come up with this kind of solution and so on, I think you have a lot of problems to solve also about explainable AI and things like that. So I think there are also this kind of topic and which are fruitful for the future.
Yeah, that was exactly my question, is if we consider a subsystem as a software subsystem, which is an AI subsystem, at some point you will have to verify that the subsystems behave as expected. So how can you verify that the AI-based subsystem behave as expected if you are not able to explain how it works? How systems engineering can help consider that?
Actually, one of the reasons why we would like to couple the simulation optimization and AI in supply chain management is the reason why we would like to understand the response of AI. In the case of simulation and optimization, when you model the system, you describe the system. Okay, it's a really process-based modeling, and we hope that actually by coupling these techniques with the optimization and simulation type techniques, we can capture some meaning to what we are getting. So that's why we try to do this coupling. But this is a real issue. This is a real issue because we would like to understand why we get this answer, and we would like to trace it and validate it on other issues as well. And we hope that, you know, in terms of repeatability of experiments and this type of questions, maybe these technological labs might be interesting, because sometimes we cannot do all this type of different tests in industrial environment.
Maybe one additional question before we close the session.
I appreciated very much the part of your talk where you explained things about AI, but a question that or a problem that I encountered myself, and I think most researchers in the field of AI, is the data. Usually when you work on a problem, let's say a very specific problem, you want the data, but access to this data is often restricted, or there are some confidentiality clauses, etc., which limits your access to this data. I want to get your take or your experience on this issue, if possible.
So thank you for your question. Actually, this was the whole point of the presentation. With the example case that I gave you, we had access to data. The company was giving us data, but you know, the usable data was a problem. Okay, and in some other industries, it's the access to data. So we have other industrial partners with which we are trying to work on this, and now industries, I'm not going to name the company, but they have a conscience about this right now. They say, okay, maybe some of the data is no longer, you know, some historical data is no longer confidential, actually. But to protect it, they are overprotectious about it, and I think this consciousness is increasing in industries as well. And today, when we discuss with them, they say, "Well, okay, actually, some of the data, maybe we can just put this available, and this could be open data, and researchers can work on it, and we can also get some valuable feedback from the researchers, because they will be working on this data, which is no longer really crucial or strategic in the company." So there is this consciousness. We see it with some of the industrial partners, and we are working with them right now to see how we can maybe make available some open source data, real industrial data, and maybe disguising some of the by disguising some of the data, not giving detailed process names or product names, and so it's really, I think, it's mindset of the companies as well, that I believe they are getting more open to ready to share. I cross fingers because we are working on it right now, and they seem to be open to that, and we will see it. And and sometimes, like we said, it's not because you have data that you can do something about it, because when you clean it, sometimes you are not left with much, and you have to complete it, and this takes a lot of time. And we are really hoping that the technology platforms like this one can be a source of open data that we can share with research community.
Okay, I think it's time to close the keynote session and move to the parallel session. Thanks Gulgun and thanks Pierre. Maybe you have some additional information today for the organization, please.
Yes, because we like a lot digital twins and information communications, I will need to make two notifications. The first one is that we try to make a tower of platforms tomorrow, and we will need your physical work in order to register in 4 groups at the reception. So you can do that during the pause. There is 2 paperboards in the reception just to create a group A, B, C, and D, about 20% per group. And we will start this tower tomorrow morning at 8:15. You understood that artificial intelligence is something which may be quite theoretical. With the platform, we try to make it very pragmatic. So that's the first thing I would like to say. And the second one was on the board. Maybe you saw it at the beginning. We will go to the Art Museum this evening, starting at 7:45 from the reception or from the main gate, whatever. So after the cocktail will be at the lunch zone, and we will leave all together to the Art Museum for the visit. Thank you very much. Have a good scientific sessions.